In the previous class, we have discussed about the properties of the acids. But in this class, we will discuss the properties of the bases. We have seen in our daily life, that is the caustic soda. The next, the lime. The next, the washing powder. These are basic in nature. These are better in taste. If you got soap sometime during washing or the bathing, then you test it that it is bitter in taste. When you touch it, it is slippery in touch. That means these are the characteristic of bases. A base turns what? Red litmus paper to blue. To the next, water bases, metal, metal oxide, metal hydroxide, metal carbonate, metal bicarbonate, ammonium hydroxide. These are found to be bases. To the next, we will discuss alkali. But so far, what we have discussed? Bases, that properties of bases. First one, caustic soda. The next one, caustic soda, lime, washing powder, these are bases. The next one, what? The bases are better in taste. As we have discussed, the acids are sour in taste. The next is that the bases are slippery in touch. The next, the bases are slippery in touch. The bases turns what? Red litmus paper to red. But the acid turns red litmus paper to blue. The next, what we know, the acids, the bases are opposite of acid because the bases neutralizes acids. What we have discussed? Caustic soda, lime, washing powder, these are bases. We also discussed that the bases are bitter in taste, the bases are slippery in touch, the bases turns red litmus paper to blue, the bases are opposite of acid because the bases neutralizes an acid. To the next, metal hydroxide, metal oxide, metal carbonate, metal bicarbonate, metal metal hydroxide, metal oxide, metal carbonate, metal bicarbonate, and ammonium hydroxide. Ammonium hydroxide are gases. To the next, we will discuss what are alkali. Alkali, it means the bases which are water soluble. It means the base or the substance, metal oxide, metal hydroxide, which dissolve in water to form basic solution. These are termed as bases. It means the soluble bases are termed as alkali. These are important to us because in this chapter only we will discuss about alkali because they have tendency to solubilize, to go in liquid solution, and therefore they can be easily studied. Therefore, in this chapter we will only and mostly will discuss alkali. What are alkalis? The water soluble bases. Water soluble bases are termed as alkalis. The next, these are important to us. Important to us because they only form what? They only form solution, and hence easy to study their chemical properties. So the next, what are alkalis? For example, what we have? Sodium hydroxide, NaOH. The next one, potassium hydroxide. The next one, calcium hydroxide. The next one, magnesium hydroxide. And the next one, ammonium hydroxide. These are termed as bases. What we have discussed. Alkalis, the water soluble bases. It means those bases which are soluble in water. They are termed as alkali. Why we are discussing about the alkali? Because we can predict the chemical property in only and only solution state, not in the gaseous and not in the solid state. Therefore, they are important to us because we can know their property because they have tendency to form solution. Hence, they are important to us. The next one, what are the example of alkalis? These are sodium hydroxide. These are potassium hydroxide. These are calcium hydroxide, magnesium hydroxide, and ammonia. Now we will discuss the next topic, that is what is common in all the bases. What do common in all the bases? Let us discuss them. Let us take the example of sodium hydroxide. What happens? When it is dissolved in water, then sodium hydroxide is broken down into aqueous sodium plus together with hydroxyl ion. If we take another example, such as potassium hydroxide, then it will be dissociated into aqueous potassium and hydroxide ion. If we take another example, such as calcium hydroxide, then in that case too, it forms calcium 2 plus aqueous plus 2 hydroxyl ion. If we take the next one, magnesium, then it forms what? Magnesium 2 plus aqueous plus 2OH minus aqueous. What we have concluded in all this, these are bases, and what we conclude? We conclude that all these bases dissolve in water to give hydroxyl ion. It means what we conclude, that the bases are those substances which dissociate to produce hydroxyl ion. What is common? Let us see. This one is hydroxyl. This one is hydroxyl ion. What we conclude? Bases are those substances that dissociate to produce what? Produce hydroxyl ion. That is OH minus. It means OH minus. It means all the bases will provide you hydroxyl ion. So the next we will discuss what is concentrate and what is dilute bases. The next one, concentrate and dilute bases. Concentrate bases are those bases which have lesser amount of water in them. If they have lesser amount of water, then they will greater amount of hydroxyl ion, and so for that they are termed as concentrate bases. Whereas dilute bases, they have greater amount of water and hence furnish lesser amount of hydroxyl ion and termed as weaker bases. What we know, a concentrate base contain little amount of water The concentrate base contain little amount of water and hence give more and more hydroxyl ion. Is hydroxyl ion is a concentrate base, whereas whereas a dilute base contain higher amount of water, higher amount of water, and hence give lesser amount of hydroxyl ion. Therefore, it is termed as dilute bases. In the next, we will discuss what strong and weak bases. But what we have discussed concentrate and dilute bases. Concentrate base is a base which contains lesser amount of water. It means it will furnish more and more hydroxyl ion per unit volume. But when we add water to that base, on addition of water, the number of hydroxyl ion per unit volume decreases, and when the number of hydroxyl ion per unit volume is lesser, then it is termed as what? Weaker bases. One more definition we have for concentrate and dilute bases. It means concentrate and dilute bases. A base which has higher amount of hydroxyl ion per unit volume is termed as concentrate, termed as concentrate base. What are dilute bases? I have told you. But when we add water to concentrate bases, then the number of hydroxyl ion per unit volume decreases. It is termed as what? Weak bases. It is termed as dilute bases. So the next we will discuss strong bases and weak bases. We will discuss strong bases and weak bases. We have discussed in case of acid. An acid is termed to be stronger acid when it dissociates or ionizes completely in the solution and furnish greater number of proton or hydronium ion is termed as stronger acid. Whereas an acid which does not dissociate completely in the solution and hence furnish lesser amount of proton or hydronium ion is termed as weaker acid. In the same way, the bases, a strong base is those bases which ionize completely in the solution and furnish greater amount of hydroxyl ion. Whereas, on the other hand, the weak bases are those bases which incompletely or weakly dissociate in the solution to furnish lesser amount of hydroxyl ion, therefore termed as weak bases. What we know? A base which completely dissociate, or we can say ionize, which completely dissociate or ionize in the solution and give and furnished greater amount of hydroxyl ion. Which is termed as strong bases. The base which completely dissociate in or ionize in the solution and furnish greater amount of hydroxyl ion is termed as. The next we will discuss what are the example. For example, we have potassium hydroxide, we have sodium hydroxide. So next we will discuss weak bases. We have discussed weak bases are those bases which partially dissociate in the solution, or those bases which does not dissociate completely in the solution is termed as weak bases. It means those bases which does not dissociate or ionize completely in the solution giving lesser amount of